So this video is for integrated one. It is the chapter 7 D-Day 2024. So this is everything you're going to need to know for the chapter 7 test. So on number 1, it says find the missing side length and angle and name the property. So when we're looking at X is a side. We have a right triangle here. Okay. And we are trying to find this X here. With a right triangle, you can use Pythagorean theorem, where you're going to take a squared plus b squared equals c squared. And it's really going to be leg squared plus other leg squared equals our hypotenuse squared. So you want to make sure that you always have the hypotenuse in the proper spot. So my hypotenuse in this case is the 8. So that is going to go over here. My legs are going to be the 4 and the X. That's the 2 legs. So I'm going to go 4 squared plus X squared equals 8 squared. And then we're going to solve this. So in this situation, we're going to get 16 plus X squared equals 64. I'm going to subtract 16 from both sides. And when I go 64 minus 16, I end up getting a 48. Then I'm going to take the square root of both sides. So I'm going to take the square root of 48. And when I take the square root of 48, I get about a 6 point, let's say 93. So you can either give me as your answer the square root of 48 or 6.93. Now, why? The by means why. Why were we able to solve this? What did we use? We used Pythagorean theorem. Pythagorean theorem. That's what we used. Now, the next thing we need to find is our y. So when I'm trying to find my y, okay, my y is right here. It is an angle. Now we know that the angles in a triangle add up to 180 degrees. This right here means the square in the corner means that this is 90 degrees. So I have 90 degrees. I also have 60 degrees. And so I'm going to try to figure out what y is going to be. So I'm going to take 180. I am going to subtract the 60 degrees. I'm going to subtract the 90 degrees. And when I do that, that's going to get me what the y is. So when I do all of this math, I am going to end up getting 30 degrees is equal to y. So y is 30 degrees. And the reason for this is because the angles in a triangle add up to 180, or I like to call it triangle angle sum. Okay, or you can write angles in a triangle add to 180. Okay, on number 2. On number 2, it's asking us to solve for x. We have 2 lines intersecting, which means this angle here and this angle here, which are called vertical angles, are congruent. So we're going to take 5x plus 60, set it equal to 2x plus 80, and solve. I'm going to subtract 2x from both sides and get a 3x. I am going to subtract 60 from both sides, and I'm going to get a 20. I am going to divide both sides by 3, and I get 20 divided by 3. And when I take 20 divided by 3, you can leave it like that. That is acceptable. Or it is about 6.6, 7 or 6.6 repeating is what it is. Now, what allowed us to write this equation? Why did I say that these were equal? Vertical angles, which is what those are called, are congruent. And I'm going to write congruent using that symbol. That means congruent. On number 3, we have a triangle. All of these things here, okay, all of these things here are angles. One angle is 145. One angle is x plus 5. Another angle is 2x minus 30. All three of these together are going to add up to 180 degrees, okay? So I am going to take the 2x minus 30 and I'm going to add it with my 145 and I'm going to add that with x plus 5 and together all three of those angles are going to add up to 180 degrees. So when I'm doing this math, when I have things that are on the same side of the equal, I can clean it up by combining like terms. So I have an 2x and an x, which is going to make a 3x. I have a 145 and a 5, which is a 150. And I have a minus 30, so that is going to be 120. Now I'm going to solve this. I'm going to subtract 120 from both sides, and I'm going to get 60. I'm going to divide both sides by 3, and I'm going to get 20 degrees. Over here, this other one was also degrees. And that is going to be our answer. What property allowed us to do this? Triangle, angle, sum theorem. Triangle, angle, sum theorem. Let me make that triangle better. Triangle, angle, sum. Now, on the next section, we are going to be deciding if these triangles are congruent, and if so, why, and then list our triangle congruent statement. So the ones that are congruent are the following. Let me write them here. Side, 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 angle, side, angle, angle, side, angle, side, angle. And if you have a right triangle and you have hypotenuse and leg, HL for hypotenuse leg. Which ones are not? Okay, these ones are not. Okay, not. Angle, angle, which is actually going to be similar but not congruent. And side, side, angle. Okay, that one is also not going to be congruent because you can end up with more than one triangle. Okay, so for this, I'm going to draw in what they're giving me. Okay, this is where they call it dirtying up the pictures because we're going to make markings on it. So here it says that line segment TA is congruent to OS. So line segment TA is congruent to line segment OS. So I'm going to put the same marking. They also tell us that angle T is congruent to angle O. So I'm going to say angle T is congruent to angle O. And then the last thing they say here is line segment TL is congruent to line segment PO. So line segment TL is congruent to line segment PO. So I put all of those markings in. And when I do that, what I end up getting here, let me just get my little hand tool here. This is side, angle, side. Over here also side, angle, side. So that is going to be my reason that they're congruent, okay? It's congruent by my blue side, my green angle, and my pink side that I had there. Now we need to match things up when we do our congruent triangles. So first off, I need to draw in triangle. Okay, and angle T is the same as angle O in the other triangle. Angle A is in the same spot as angle S, and angle L is in the same spot as angle P. So actually, they actually drew the triangle symbol. I didn't need to draw it, but we want to draw it if they are not, if they don't draw it in for us. Okay, on B. So on this one, they tell us that angle ITN, let me just follow it for a second, ITN. So that is going to be this angle right there, okay? And that one is going to be congruent to triangle ATN. Let me trace it, ATN. So that's going to be this angle. Whoops, let me get out of the highlight. That's going to be this angle here, okay? So those two angles are congruent to each other. I'll put a little single mark, so we can see that those are not one big angle, but two separate angles. They also are giving us that angle I is congruent to angle A. So angle I, I'll put a double one, is congruent with angle A. Now that's all they gave us, but this particular side here is in both triangles. So it is congruent to itself. So line segment TN is congruent to line segment TN. So those are my markings. So now I'm going to try to figure out what's going on here. So I've got angle, angle, side. Okay, so this is going to be angle. So let me just kind of color code. So it is going to be angle. That's not there, sorry. Try one more time. It's going to be angle. And then I've got my pink angle. And then I have my purple side. Okay, that's my angle, angle, side. So then we have to state what is the congruent triangle. So T in both triangles has the same marking. I has the same marking as A. N is the same as N in the other triangle. Not always the case that the same letter is the same in both triangles, but in this situation it is. On C. So for this one, they put markings in. They did not give us any statements here. We know that this one here, let me just kind of, again, I'm going to kind of try to color code here. So this one here, line segment IN, is going to be the same as this one here, line segment MP. This line segment TN, is going to be the same as line segment AP. Then the other thing that's going to be true is this angle here is 90 degrees and this angle here is 90 degrees. Now, if I'm looking at this, okay, I actually have, as I'm going around this, I would have this orange side, then this pink side, then this angle. So that's really side, side, angle, which is not one of these. However, it is a right triangle. And for a right triangle, we can have hypotenuse leg. So it has to be your hypotenuse and your leg. So in this situation, our hypotenuse is the one across from our right angle. So you see, I do have my hypotenuse. And then the other sides that are not the hypotenuse are legs. So I have hypotenuse leg. So we're going to be calling this hypotenuse leg. Okay. So my hypotenuse is the orange line I drew, and my leg is the pink one. Now, what goes with angle I in the other triangle? And in this case, they didn't draw the triangle, so I'm going to draw the triangle. So what goes with angle I is angle M. What goes with angle N is angle P. What goes with angle T is angle A. On number 5, so we have parallel lines cut by a transversal. Just a little reminder in terms of terminology. Anything that's in between your two parallel lines are interior angles. Anything that is outside of your two parallel lines, okay, Those ones that I have in purple, those would be exterior angles. So the ones in the orange are interior angles, and the ones in the purple are exterior angles. Okay, so they tell us that measure of angle 2 is 120 degrees. So we know that this is 120 degrees. Now, I can fill out the rest of this. If that is 120 degrees, then this is also 120 degrees because those two are vertical angles. We have this line here and this line here intersecting. So those are going to be vertical angles. Now, if this angle 2 is 120 degrees, then this angle 6 is also 120 degrees because these two are corresponding angles. They're called corresponding angles. I know that angle 8 is going to be vertical with angle 6 because, again, this line here and this line here are intersecting. That is going to make this be 120 degrees because those are vertical angles. We also know that this angle here and this angle here are alternate exterior angles. We also know that this angle here and this angle here are also alternate interior angles, not exterior, interior. Now, all of those are things that are going to add to 120 degrees. And also these two here are called corresponding. So there's a lot of different relationships going on here. Now, to find the other angles, I know that these two here form a linear pair. And when you have a linear pair, they make 180 degrees. So together they have to be 180, which means that's 60. This is going to be 60. Those are vertical. These are going to be 60. It's alternate interior with the other, with angle 3 or corresponding with angle 1. Angle 3 and angle 7 are corresponding. Angle 7 and 5 are vertical. Angle 7 and 1 are alternate exterior. Angle 3 and 5 are alternate interior. Okay, so find the measure of the following angles. So measure of angle 1. And I'm going to do this. I'm going to, on the test, they're going to say based off of. So find the measure for the following angles, and the relationship is going to be compared to measure of angle 2. Okay, we want to see what is its relationship to measure of angle 2. Okay, so measure of angle 1 is going to be 60 degrees because they are a linear pair. Okay, which means they add to 180 degrees. Now, measure of angle 6 compared to measure of angle 2. Measure of angle 6 is 120 degrees. And y compared to angle 2, they are corresponding angles. Now, measure of angle 8 compared with measure of angle 2, it again is going to be 120 degrees, but both of those are purple on opposite sides of the, or alternating sides of the transversal and exterior. So these are alternating exterior angles. Now it's asking us, why is angle 3 and 7 the same? So 3 and 7 are the same because they are corresponding angles. That's what they are called, corresponding angles. Now, the next section is dealing with constructions. Okay, I'm going to get my compass. They want us to do I'm going to get two different colors here. They want us to do a perpendicular bisector. So I am going to put, and let me just kind of get this, shrink this down a little. Okay, so I'm going to put and we can make it as long or as short as we want, but we want it to be more than half. Okay, so let's say I want it more than half. Okay, because if it is half or less, it's not going to be able to form a perpendicular bisector. And then what I'm going to do is I'm going to draw a circle. Really, I need to do a mark above and I need to do a mark below towards the center of the circle. I'm going to keep this radius. I'm going to move it over here. Let me change the color. Okay. And now I'm going to draw another circle from the other endpoint. Okay, now where these two circles meet. Okay, so they meet up here and down here. So then what you're going to do is you're going to draw a line connecting those 2 points of intersection. So I am going to draw a line going through this one and this one. And that is my perpendicular bisector. So let me just kind of highlight it. This right here that I just drew in orange, that is the perpendicular bisector. So what that means is it's going to cut the segment in half. So this side and this side are going to be the same. It's also going to form a right angle. So these are all going to be 90 degrees. On number 7, we're going to bisect angle A. So let me get my compass again. Okay, I'm going to come here. Let me just kind of make a point here. Okay, so I'm going to make a point here. So I am going to draw a circle from point A that needs to cross both of these angles here. Okay, so as long as I can cross both of these angles, okay. So let me draw that circle, and I don't need to go all the way through as a whole circle. I just need to touch at those 2 spots. I have a point here that it crosses, and I have a point here that it crosses. Okay. So now I'm going to keep the radius the same. I am going to move, and let me just kind of turn this. I'm going to move my compass here to draw a second circle that has the same radius. And I am going to be drawing it through here. Okay, I want it to go in between the 2 sides of the angle. I am now going to draw a third circle with the same radius. I'm going to go to this red point here of intersection. And I'm going to again draw, and I want to see where those 2 crossed. Now, where those 2 cross at this point here, I am going to draw a line from there to my vertex at A. And that line I drew, that is going to be, let me draw it straighter, sorry. That is going to be my angle bisector, cutting that angle in half. Okay. Let's look at number 8. So on number 8, they want us to plot these points. They want us to plot -3, 4, 1, 2, 3, 1, 2, 3, 4. Okay, let's call that A. They want us to plot B, 2, -1. So that is B. The line that connects these, that is the length of AB that I'm trying to find. So I can do a right triangle, and I want to figure out those lengths. So here, let me just kind of color code these. So try again. Sorry, just get that out of my way. Okay, so let's say I've got that length, and then let's say I have this length that I'm looking at. I'm just going to highlight them so you know that that's not really part of what I was trying to draw. I'm using this to find the length. So I'm going to count 1, 2, 3, 4, 5. I'm going to count 1, 2, 3, 4, 5. So in this situation, I'm going to do Pythagorean theorem. I'm going to go 5 squared plus 5 squared is equal to, I'm just going to call this D for distance squared. So when I add those together, I am going to get 50, 25 and 25. 50 is equal to D squared. I'm going to take the square root of 50. Okay, that's an acceptable answer. But if I take the square root of 50 on my calculator, I end up getting about a 7 point, let's say 0.07 is about the length. And that would be your answer. On number 9, they want us to prove this. And we're going to kind of do this where we're just listing kind of the information and why we're saying it. So first thing I notice is they gave us this marking and this marking. So that is saying that angle D is congruent with angle A. And my reason for this, given, they told us that. Okay. I also see that they gave us this. If line segment LD is congruent to line segment NA. So line segment LD is congruent to line segment NA. So I'm going to write that too. LD is congruent to NA. And the reason, I'm going to again say given. They didn't draw it in the picture. They stated it to us. Now they want us to prove that these triangles are congruent. I, at this point, don't have enough information, but I do notice that I have 2 vertical lines. When I have vertical lines, I am going to end up having these, sorry, I have 2 lines intersecting. I'm going to end up with 2 vertical angles. Those 2 vertical angles right there are going to be congruent. Now, the one in this triangle, let's say I color this triangle green. Okay, so this one in triangle, the green triangle versus the orange triangle. Okay, so if I'm talking about that angle I in the green triangle, I cannot call it angle I because there's too many angles at I. So I'm going to call it angle LID. Notice that the I, where the angle is in the middle. And I'm going to say that that is congruent to angle. And the other one I'm going to call, let's say, NIA. Again, the I is in the middle because that's where it is. And then the reason this is true is not given. They did not give it to me. It's because I know that vertical angles are congruent. Now, from my picture, I have enough information to say that triangle DLI, which is what they gave me at the top, I'm just following their order, is the same or congruent to triangle AIN, sorry, ANI, I apologize, ANI. And the reason for that is angle, side. So angle, side congruence. And that is a proof. On the next problem, okay, on 11, it says if f of 1 is 2, give the first 5 terms for the sequence described by f of x is equal to f of x minus 1 times 3. So really, this is f of x is equal to f of x minus 1 times 3. Okay, that's what that, they wrote it as a x for the multiplication, but it's times. So I'm going to start with my first term. They told me the first term is 2. Here, this is recursive formula telling me that I'm going to times by 3. So it's going to be 6 times by 3, 18 times by 3, 54, and so forth. And the only one that follows that pattern is letter D. On number 12, we're going to solve this system of equations. I am going to multiply, because I'm going to use elimination, and I'm going to try to eliminate my y. I'm going to multiply the bottom equation by 2. So I'm going to keep the top as is, 5x plus 2y equals 16. I am going to, for the second equation, now have a 6x minus 2y is equal to 28. I'm going to add these two equations together. I'm going to get an 11x, my y's cancel out, is equal to 4, carry my 1, 44. I'm going to divide both sides by 11 and get 4. My x is 4. Now, I would put that into one of the equations to get my y. In this case, there's only one situation where my x is 4, so that is my answer. On number 12, again, we're going to solve this system. I'm going to use equal values. I'm going to take 2x minus 9 and set it equal to 3x minus 14. Since both equations are equal to y, I can set them equal to each other. I'm going to minus 2x from both sides. That's going to give me a negative 9 is equal to, let me actually do the subtraction, 2x minus 14. I am going to add 14 to both sides, which is going to give me a 5 is equal to x. Now, I can't stop here. You might see 5 as an answer, but that's x being 5 that I have. The answer there is y being 5. So I need to find my y. So let's say I put it into the top one. Y is equal to 2 times 5 minus 9. So I'm going to get 10 minus 9, or 1. So C is going to be my answer. On number 14, using the image below, match the vocab word with the mathematical notation by marking the box. Okay, so domain. Domain is, let me just kind of draw a vertical line here. Okay, let me actually do it with the line tool so it actually will be vertical. Okay, so domain is how far to the left and how far to the right. So the furthest to the left I go is -3. The furthest to the right I go is 2. And it's including both of them. So my domain is going to be that. Now my range is, let me draw another vertical line. My range is where I want to see how high and low. So the lowest it goes is -3. The highest it goes is 4. So that is going to be this one here, -3 to 4. Now, there's only one choice left. So for equation, it's going to be the one in the middle. But just let's say you had more than one choice. If I'm starting here to here, how am I moving? I'm going down 1, 2, 3, 4, 5, 6, 7. And I'm going, so down 7, and I'm going to the right 1, 2, 3, 4, 5. So I went down 7 and I went right 5. And my y-intercept, if I look and see, where does it cross? It crosses at 0. So my y-intercept is 0. So the equation is going to be y equal -7/5 x, because my slope is down 7 to the right 5. On 15, we want an order pair that is a solution. So I'm just going to plot all of these. Okay, so this one, let me just kind of color code these so we see which one's which. Okay, so my first one 0, 0. No. My next one 0, 4. And we got to be careful the way they're scaling it, 2, 4. So that one looks like that is a solution. Okay, so this one looks like it is a solution. Let's just double check out the rest just to make sure. 0, -2, no. 2, 6, 2, 6, not quite. So the only one that did work was B. Okay, laws of exponents. Okay, so when we are doing these problems, we want to remember that I am going to be multiplying the coefficients with each other. I'm going to be looking at the x's with the x's and the y's with the y's. So when I'm doing this, negative 4 times 2 is going to be a negative 8. My x to the 5th and x to the negative 8th is going to be x. I add the exponents, so 5 and a negative 8 make a negative 3. I'll deal with that in a second because I don't like negative exponents. And then my y to the 3rd and my y to the 4th, I'm going to add those and get y to the 7th. Now, the part that I don't like is this. I'm okay with my coefficient, my negative 8. That's okay. It's a coefficient. It's not an exponent. Okay, it's a normal number. So my negative 8 is going to stay where it is. My y to the 7th is going to stay. And what's going to happen is that x to the negative 3rd is going to go down, and that is going to be my answer. And so that is letter C. And that's the end of this video. Hopefully this helps us out if you're not understanding any of the problems. But again, you want to make sure you know how to do each of these for our test for chapter 7.